All right, let's dive right into an absolutely stunning architectural blueprint that literally bridges theoretical mathematics with the future of artificial intelligence and quantum computing. Welcome to The Explainer. Today, we are immersing ourselves in a profound transformation. We're talking about a space where elegant numbers don't just sit statically on a page, but actually evolve into active physical reality. We're looking at a framework that has the potential to completely rewrite how we think about computational architecture.
What we've got here is a visionary schematic created by Emily Newton, building on some truly groundbreaking concepts. It transforms static mathematical formulas into a continuous dynamic computational field. And just look at that classic architect style, the meticulous blue ink on a cream grid background. It is a striking visual representation of biomimetic engineering, perfectly unifying geometry like Pascal's triangle and the Fibonacci sequence into one cohesive, flowing structure.
Now, this entire model, and really this whole explainer, is dedicated with deep admiration to the foundational work of Jean-Claude Perez. You see, Perez originally discovered the underlying combinatorial structure of this hourglass geometry, and Newton has dynamically incarnated it into what we now call the Perez Hourglass Field Equation, or the P-HFE. It's an incredibly elegant mathematical architecture that's finally being brought to light.
So, here is our blueprint for today. We'll briefly cover the blueprint of future computing, the concept of computing sand, biomimetic gears, AI associative memory, the quantum incarnation, and finally, wrap up with room temperature quantum processors.
Okay, Section 1. The blueprint of future computing, unveiling the PHFE. Let's lay the foundation. There's a quote here that I absolutely love. The sand is no longer falling, it is computing. Think about that for a second. It perfectly captures the core thesis of the entire Perez Hourglass Field Equation. We are fundamentally shifting away from the passive tracking of time, where particles just drop via gravity, into an active computing field of energy, where every single movement is processing information. Moving right along to Section 2, the concept of computing sand, from static math to dynamic fields.
This really hits the nail on the head when it comes to illustrating the paradigm shift. We're watching fixed configurations evolve into a continuous, real-time field evolution. It's kind of like water turning into a whirlpool. The structure itself drives the momentum. On one side, you have the static object, fixed, motionless math. On the other, that math undergoes an evolutionary phase transition. The structural patterns, like Fibonacci symmetries, are no longer just pretty shapes we observe in nature. They are the active mathematical gears driving a computational field.
All right, Section 3, biomimetic gears and architecture, the engine of the hourglass. So, how does this machine actually run? Well, it uses familiar structures like the Fibonacci sequence and Lichtenberg tree branching, but again, not just as geometry. They act as the physical gears generating the field's directed growth. You've got the golden drive injecting scale-adaptive self-similarity, spinning out at that famous golden angle of 137.5 degrees. Then the fractal Laplacian promotes scale-free stochastic branching. Think of the way lightning forks or tree roots spread. It's this perfectly directed chaos guided by underlying mathematical order. Now, you might be wondering, how on earth do you keep a dynamic system like this from just spinning totally out of control? Well, think of Theorem 7 as the ultimate structural integrity of our blueprint. It is an unbreakable shield of symmetry, ensuring the machine doesn't shake itself apart. By strictly mirroring the additive growth of the North Hemisphere against the subtractive refinement of the South Hemisphere, Theorem 7 enforces perfect symmetrical defects right at the center, essentially locking out all that chaotic noise. When you bring all these gears and protections together, you get this. Just a breathtaking look at the classical machine in its entirety. You can see the intricate folding, the mathematical DNA, and the protective shielding all meticulously engineered into one continuous, dynamic computational field. It really sets the perfect stage for real-world application.
Next up, Section 4, perfecting AI associative memory, the classical engine, which we call FAM.
So, FAM, this is a total game changer. We're taking that theoretical fractal geometry and turning it into a functional computing system that literally never forgets or distorts information. If you've ever had an AI chatbot hallucinate wildly or forget earlier parts of a conversation, you know modern AI really struggles with noise and data decay. But this associative memory architecture, it offers a fault-tolerant solution built directly into the mathematical physics of the system itself.
Imagine feeding the system a chaotic, super noisy signal. The hourglass takes it, runs it through a golden ratio modulated recurrent memory kernel, and thanks to the absolute parity enforcement of Theorem 7, it manages to perfectly restore the original signal on the other end. We are talking about ultra-resilient data retrieval that can survive extreme noise interference. It's practically bulletproof. Okay, let's turn the page to Section 5, the quantum incarnation, upgrading to Q-PHFE. This is where things get really wild. This comparative breakdown shows how the sand is no longer just computing dynamically, it's now computing in superposition. Notice the evolution here. The mathematical core upgrades to handle quantum wave functions. The noise mechanics adapt to stochastic Lindblad channels to manage the quantum environment's tendency to leak information. And, perhaps most importantly, the drive upgrades from standard golden harmonics into something incredibly profound called 5D modular oscillators. Look at the anatomy of this quantum upgrade. The classical Ginzburg-Landau core essentially evolves into a nonlinear Schrödingerian-like equation. This right here represents the completed analysis and synthesis of the Q-PHFE, incorporating the latest V1.1 addendum and erratum quaches by Emily Newton. The foundational concepts of Newton and Perez are pushed to their absolute limits, enabling stable, noise-resilient associative memory to operate entirely within a state of coherent quantum superposition. We can essentially break this quantum machine down into these core mathematical engines, each serving the highly specific biomimetic function. You have the fractal Laplacian for scale-free branching, the Ginzburg-Landau potential to guarantee stable physical pattern formation, and those carefully tuned Lindblad channels to manage the inevitable decoherence you always find in quantum environments. But the absolute standout component here, it has to be V mod 5. This is the engine of coherence that creates fractal interference patterns across multiple dimensions simultaneously. It is absolutely crucial because it maps the noise-resilient protections we just saw in the classical AI model directly onto quantum probability states. It's literally the bridge that makes quantum associative memory mathematically viable. Which brings us to our final section, Section 6, Room Temperature Quantum Processors, the Ultimate Realization. All right, here's the absolute biggest revelation of this entire explainer. By utilizing this Fibonacci vortex, we are talking about achieving fault-tolerant quantum computing natively at room temperature. Let that sink in. Operating at roughly 80 degrees Fahrenheit or 300 Kelvin. No massive cryogenic cooling systems needed. No heroic error correction overhead. Driven by the MSRJD action, the native dynamical law of this equation provides unbreakable topological protection just by existing. And it's not just theory. We are already seeing the mathematical proof of concept. They've successfully mapped 3-qubit quantum Fourier transform right onto this exact PHFE vortex register. This means natively implementing complex quantum calculations and exponential speedups directly on the mathematical structure. The Fibonacci vortex is literally doing all the heavy lifting that previously required unbelievably delicate and expensive hardware. So I'm going to leave you to ponder this incredible architectural blueprint where our understanding of reality just got a whole lot more elegant. Think about it. If the universe inherently computes using the golden ratio to run everything from DNA to planetary dynamos, shouldn't our quantum computers do exactly the same? The math says yes. Thank you so much for joining me on this explainer. Keep learning, keep exploring, and I'll see you next time.